Hello everyone, welcome to the video. From this video we will start discussing some of the important algorithms in data science and artificial intelligence stream. We will discuss these algorithms in details with full intuition and math behind it. So before discussing them, I will try to motivate you why this field is so important, what are the various use cases of this stream, and what is the general paradigm followed in various algorithms of this stream. So this is a introductory video. Let's see what are the popular use cases of data science and artificial intelligence. What is artificial intelligence? Many of you might be knowing that it is making a machine to learn a certain human-like task. What are the popular examples? Many of you might be aware of that self-driving cars, voice control virtual assistants, chat GPT. You might have heard about it, you might have known about it, so we'll see what are each of these use cases are. This is a self-driving car case. There is no human sitting. Machine is driving the car. According to the image or scene, it is seeing through the camera. So it is taking various decisions whether to accelerate, whether to go straight, whether to take left, whether to take right, whether to reverse. All this decision is taken by machine, not a human. This is one of the popular use cases of artificial intelligence and data science. Another case is voice control virtual assistant. You might be aware that these are very popularly known as Alexa and Siri. Siri is from Google and Alexa is from Amazon. What happens here also, certain person is speaking, it is taking voice as input, and the machine is interacting with that person just like any other human being is interacting. It is responding, it is answering his question. This is one more popular use case. From recent time you might have heard about chat GPT. This is also very popular. If you notice, it is taking input as text. So you are writing something, you are writing some question, the machine is responding to that question with elaborate answers. Let's say in this case, this question is being asked by a human. So machine is responding to that question, how are you, chat GPT? So machine is responding with certain statements. And similarly, it is asking some different question and the machine is responding. So in this case, the input is text and output is again a dialogue or interaction or question answer. In all of these use cases, if you notice, there is certain input and there is certain task. Let's say in self-driving cars, if you see that what is the input? Here input is image or video, right? Image or video of a car, of a scene in which car is being driven. And what is the output? Output is driving a car, or that is output task basically. Output task is driving a car. So this includes everything, taking a left, taking a right, whether to go straight, whether to take, whether to do reverse, whether to accelerate. All this decision is output task at a certain moment. Machine is doing all this. So this could be categorized as certain input and certain task output. Here also there is certain input, right? So input is here input is voice. And what is the output? Output is interaction with that human, right? Interaction or question answering. Machine is doing all this. Again, in chat GPT case, if you notice, there is certain input. So input is in which form? Here input is in text form. And what is the output? Output is again interaction. So output again is in text form, So again, interaction or question answering. So if you see that the machine is taking input in various forms, so image, voice, and text. So it is analogous to human understanding, right? So human is also taking input for a various tasks, mainly through these three sense organs, right? One is eye, one is ear, and so if you see eye, you can mention it like a picture or image. And again, through eye, he can, it is taking input in a form of, let's say, text. So all of these has a certain correspondence in, AI domain also. So if it is, image, human is reading an image, then the corresponding correspondence is, computer vision or self-driving car. So it has a correspondence computer vision. For ear, it has a correspondence speech recognition. So these are various branches evolved out of this data science domain. And if it is text, then it is generally referred to as a natural language processing or NLP. So left side is a human input, and right side is ML or machine learning counterpart. So for all of the input forms, various branches evolved for a machine learning counterpart. So but those of you might be, many of you might be aware of the general computer system. So computer is usually taking input for a computer or a machine. The input is always or data is always a binary or a number, certain number. But we have seen that it is taking input as image, it is taking input as voice, it is also taking input as text. So all of you, so all of this has a certain correspondence with this binary or image case. So for image, so if you see here, image is generally 3-channel image which has a red, green, and blue channels, and each channel have a number, certain integer 0 to 255. So those of you might be aware how the image is stored. This is certain format in which it is being stored. So again, if you see that this is certain number itself, right? So machine can process this. For a text, if you see, text also has a certain ASCII counterpart, and it could be also represented with certain number. So that is also number. It need not happen that machine is only processing the ASCII numbers. So one of the way is each word in your vocabulary you represent with a certain vector, with certain binary vector. So let's say if you have let's say D words, let's say if you have a D word dictionary, then the binary vector, so the binary number for ith word is all word position is 0 except the I. So 0 0 0, like this it will go, and for ith position I will keep 1 and other I will keep again 0. So this is ith position. So this is one way. This is one way I can represent a word in a binary or a number format. Okay, there are various numerous ways. It need not happen that machine is only processing this way. As we go further, we'll see that there are more sophisticated ways to encode a word into certain number. So this is one way which generally is being referred to as a one-hot encoding. One-hot binary encoding, I would say. So this is one-hot encoding. This is not an optimal way to represent it, but I'm just trying to demonstrate that there are obviously ways to convert a text also into the number or binary number. Also similarly speech also. So speech is speech is nothing but voice or voice counterpart of text only. So this is usually done by encoding analogous voice signal to text and then converting to binary numbers. So if I have some way to encode or convert, then I can also obtain the binary representation of voice signals also. So then converting to number or binary number. So in machine learning algorithm, in general, so any input will be encoded into binary or number format. So there is certain input, let's say it is encoded into binary or number format, and there is some unknown function f which machine is supposed to learn. This f is unknown, we don't know it, and that's why machine learning is important, because we want machine to learn this function somehow, and after learning this function we want machine to give certain output, which is f of input, it is certain task output. So let's say in self-driving car, this output could be certain decision, take left, take right, go straight. For a chat GPT or for a voice controlled virtual assistant case, this could be responses, question answering, anything. So basically there is certain unknown function of the input, and this function we want a machine to learn this function. So where does the term data science creeps in? So if you see how the human is learning to perform a certain task, it learns to perform a task through certain experience, right? So let's say if he wants to drive a car or bicycle, it will learn to do that through certain experiences. So similarly machine also, it will learn to perform a certain task through certain experience. So experience is nothing but a certain amount of data, right? So from a certain past data or a certain past experience, it will learn to perform a certain task. So there is no learning without any prior data. So for any task, let's say a human has to drive a car or do interaction or to do question answering, it has to have a certain past experience. So even if you ask a question in certain language, let's say in English language, it should know that certain word has a certain meaning, and after that it will try to comprehend the question and then answer accordingly. So there is a data. Certain past data is always coming into the play when human is performing a certain task, and that's how we will also make a machine to learn to perform a certain task through past data. So That's why the term data science is very important, and there is no learning without data. There is no learning without data. So that's why this term data science. So this data in which we are trying to make a machine learn or a machine to perform a certain task is always a limited. So data is always a limited. We don't have all possible scenarios of that data. So let's say if we want to make a machine learn to drive a car, so we don't have all possible scenarios on which car could be. So we do only have a limited scenes data. So data will be always limited, even in question answering or chat GPT case. The number of possible questions that are being asked is always limited, and we can't even imagine to make a data set where all possible type of questions could be asked. So that will not be possible to even make those kind of data. So data will be always limited. From this limited data we want machine to learn to perform a task. So that is a setting we have. So let's say we want a machine to perform a simple task, given an image, identify whether it is cat or not. So how a certain human will identify? It will say that okay, there are certain ears, there are certain eyes, there are certain nose. Of course, these are not sufficient. It will see the shape of the nose, texture of the nose, texture of the eyes, ears, shape of the animal, all those things. It will try to recognize it and then finally make a decision whether that is a cat or not. So similarly, there are some inherent characteristics of a task. So which we usually refer to as a feature. So these inherent features we want a machine to detect automatically through the data we pass. And so let's say in this case, very simply we have mentioned that there are three features mainly, let's say nose, eyes and ears, and machine will try to detect these cases and identify those objects in the image, and then it will classify whether that is a cat or not. Of course, these are not sufficient. It will identify many more inherent features, but for our understanding, we don't even know what exact features it will identify. But somehow we want it to be record these features inherently through the data we pass. So here the term inherent is very important. So we want a machine to inherently detect these features or learn these features. So this is a general approach in the machine learning or data science algorithm. And why let us see why we want a machine to learn instead of human. So one obvious thing is the machine is always faster in computation. So you might have even observed that for a certain task, machine is many times faster. So even in chat GPT, you write a query, it will give the answer in very fast. So it is faster in computation, and human knowledge is always limited by individual capacity or knowledge. So for a certain task, certain human might be good. For a certain other task, a certain other human might be good, because their knowledge are structured in that way. But the advantage with machine is we want machine to be good in almost all the tasks. So let's say if you see chat GPT, it can answer a question on history, politics, any domain you pick up, finance. So that's the advantage of machine, right? So you can make it to be proficient in any of the domain. And there are certain scenarios also. So there are certain chess bots. So these chess bots, basically these are AI bots, and chess bot or chess AI bots. So they beat world. There are certain competitions held, chess competition between these bots and the champion player. So in many of the cases, these bots have beaten beaten a world champion also, beaten a champion chess players. So that's how wonderfully this domain is being progressing. And machine is performing a task way better than a single human can perform. So that's why this machine learning is so popular and useful. So let's finally see this data that is being used in machine learning or data science algorithms, how these are being used, and how this data is being divided. So this data is mainly divided into two segments, training data and test data. So training data is a actual data where we want a model or a machine to learn a specific task. So please note that model and machine will be used interchangeably. So both we mean same thing. So test data will be data where we estimate model performance. So as we have already discussed, we have certain limited amount of data, and even in that data we are partitioning the data between two categories. Final data will be partitioned into training and test. There is also validation test data, so I'll not go into the detail. We'll discuss it in later videos also, but this is just for understanding. So these two segments we divide the data, and this segment will be used for making machine to learn. So machine will learn from this segment, and from another segment we evaluate how good the learning is. The reason to keep it separate is since we already use this data, machine is known to perform good on this data, and there is separate data which is being kept just to evaluate how good the learning is, or how good the machine learning is. So these are the general two classes in which we divide the data, which is training data and test data. And test data is basically unseen by the model, and it is just used for estimating the model performance, and we want a model to do good in this unseen data or a test data. So again, why to keep it separate? Because one data we already use it for a machine to learn, so machine will already doing good in this data, and because machine has seen this data, and there is separate category on which we evaluate the machine performance or a model performance, that how good the learning is. And we will see these categories frequently when we individually see data science algorithms, and you will get to know more about these things. So this is just for completeness I'm mentioning. So that's all, and this is just an introductory video. From next video we'll go into the specific algorithms of data science and machine learning, and we'll try to analyze it and see how those are being modeled. So thank you for watching the video. We'll see you in the next video.